Cool. So as mentioned earlier, this week we're going through a crash course of web. A little bit of a warning first up is that this is going to touch on a lot and not really go in depth. It's going to be more of a breadth versus depth thing. So if you are interested in any of these particular attacks, take a screenshot now. This will actually be, these are basically just resources or YouTube videos that explain them in a bit more detail and at a much slower pace. So yeah, I'll leave that up for a couple of minutes. Well, a couple more seconds. Cool. So really the first question here is, what is the web? Before we can actually start exploiting, we actually got to know what we're exploiting. According to Wikipedia, the World Wide Web is this. I literally just copied and pasted. I didn't even read this. Basically, the web is a global network of computers which constantly talk to each other, and it's the reason you can access google.com or youtube.com or even monsec.io/join. It's made up of three major parts, right? So you've got the web pages, which are kind of chunks of data that are rendered into a visual format, and it's what makes it human readable. There are the servers, which host this data, and then there are the browsers, which takes this data and makes it into that visual format. So how is the web made up then? So most modern web pages are made in two ways. The first way of making a website would be making a static website. So these are ones that are pretty much just files that sit on the server and are sent to any client that requests them. They are typically built in a JavaScript framework like React, Vue, or Angular. And this is what you get if you want to do anything like GitHub pages, for instance. These sort of websites, because they are basically just files, do require a secondary, like a program to actually serve them. This is typically something like Apache or Nginx. The other way of making it is making something called a dynamic website. Now, these are websites that are actually, that don't have a singular file that is shown to each user. These are ones that will actually change their contents based on the user's input. So think something like Facebook, where the Facebook newsfeed is constantly different every time you go to it, because it's generating that newsfeed every time you request it from the server. Some common frameworks for things like this is like Django and Flask, if you're familiar with Python, or PHP if you're old school, or still like 80% of the industry. These sort of websites don't typically need to use anything like Apache or Nginx, but sometimes they do still use them. For instance, Apache and PHP is a very popular combination. So that's sort of the high level of how it works. But how does it really work in the lower end? Well, it uses something called HTTP, or the Hypertext Transfer Protocol. This is basically, just think of it as a bunch of text documents being sent from your computer to Google and back. If you actually mess around with it and look at it in something like curl, or even like Google Chrome or Firefox's development tools, you'll see that literally what the packet that is being sent isn't even binary. It is actually just text. For instance, this sample one that I've got here is something that I sent to myself in the process of making this. So not a whole lot, not really complex, but can be a little daunting when you first see it. So let's break it down a bit. The way that a request is actually structured is that you have the first word, in which, in this case being get, that is the HTTP option, if you will, or the header, kind of different names for it. This is basically the word that says, I want to do X with the server. So in this case, I am getting I am getting index.html. So I am requesting the server send me that resource. There are also some other ones like post, which is saying, okay, I want to send data from myself to the server. So get gets it from the server, post sends it to the server. There are also some other ones like connect and put and which and stuff like that, which are kind of more advanced. You don't really need to mess with that for the most part, but they can lead to very interesting things later down the line. After that, you've got the resource being requested, as I said before, and then the rest of this is pretty much just metadata of what's going on. So HTTP/1.1 is just saying use 1.1, the 1.1 version of HTTP. You'll see this in pretty much every request. Then the host header is where it is being sent to. So in this case, I was pinging my home IP or my local host IP, which is why it's 127.0.0.1. I was using the program curl to do this. So the user agent was curl. And the last line you don't really need to worry about. So once you've actually sent this off, you will hopefully get a response back. This will be like the actual HTML file. The HTML files are typically the just strings of text, another text document, which are then rendered out. On these responses, they will also typically come with a status, so a status code. If you were to successfully get it, it would be 200 OK. If you were to, for instance, go to hotmail.com, which is no longer hotmail.com, but is actually live.com, you would get a 302 error, which redirects your browser to the appropriate location. And the last thing I want to mention about the HTTP protocol is that it is a stateless protocol, which means that it doesn't have memory. If I get google.com now and then get google.com again, those two requests will be identical, almost. It won't know, like just by itself with HTTP, it can't tell if I was the one to request it or if you were the one to request it. But that doesn't really work in the world where we want to be able to log into websites, right? So then we introduce something called cookies. Cookies are basically, again, little text documents which store information. In this case, they would store things like authentication codes, usernames, stuff like that. And they will be, your browser will store those, and then they will be sent to the server with every subsequent request afterwards. So that's how you can transfer from facebook.com, like the login page, to the newsfeed, and between those two requests, it knows who you are. It's because of the cookies. Typically, cookies will store all kinds of data, not necessarily just strings and text. It will also do things like Boolean values, or it will store things like numbers, integers, stuff like that, which don't necessarily use ASCII values. In that case, how do we actually store that sort of data in a text document? Well, we use something called base64. Base64 is a method of encoding where instead of taking instead of taking the data in 8 bytes or 8 bits per byte, you do it at a slightly different, You do it at a slightly different, like chopping section. So it will have, it will make sure that every single, basically every single like every single string of binary has an ASCII representation. It's a way of encoding anything from a Word document to an MP3 file in a text string. Interesting thing to note here, you can easily tell if a string is base 64 just by guessing if you see these two equal signs. Forgot what they were then. Equal signs there. This is because the base 64 encoding needs a very certain size, and it can only work in multiples of that size. So if it doesn't have multiples of that size, it will need to add some sort of padding to it, in which in most cases it will be this equal sign. So yeah, that's just a little trick. This is how cookies are stored, but it's not the only thing that uses base 64. Base 64 can be seen everywhere, from file uploads to requests. So that's kind of the basics of it. If you want to research this a bit more, these are sort of the key points of the protocol that I would recommend looking into. We have the requests here and kind of what they do. And then we have the sort of responses that are interesting. You've got things like internal server error. So if you do get a 500 error, you know that you've screwed something up and potentially there's an exploit there. So maybe screenshot that one again and look it up in your own time. But moving on to the more interesting question now. That was the theory of it. How do we actually break the web? Well, we have a few different ways of breaking the web, and we'll touch on a few of those here. The first off, how do we break the front end? So that is breaking React, Vue, and Angular, those sort of front end frameworks, primarily in JavaScript. The first one here is XSS, or cross-site scripting. This is when an attacker actually modifies the web page and injects their own malicious code, most of the time JavaScript, but in more recent times, you can do stuff with WebAssembly, and don't worry about it. Most of the time, you'll be looking at JavaScript. These exploits actually target the client's browser. So even if I'm sending the XSS to Google, and then you view Google, Google isn't the one executing it, you are. There are 3 types of XSS. There's stored, reflected, and DOM. And this is sort of the really big one that everyone looks for, because the HTML parsers are very different between Google Chrome, Firefox, Safari, and all those. So very typically, an XSS that works on Chrome won't work on Firefox, which means that it is highly specialized, highly targeted, and you can do a lot of damage if you know exactly who you're dealing with. So what does the XSS actually look like? Well, if you think about how HTML works, it's basically just a stream of text. Remember those text documents. It's read sequentially, there we go, and your browser reads it and then renders a web page accordingly. So what if you wanted to put JavaScript into your HTML? Well, you would use these script tags down here. What if you were able to put script tags in user-controlled input? Well, the browser wouldn't be able to tell normally between user-provided input and what the web server is telling it to do. So that's where XSS comes in, because once you've got the browser confused, you can execute arbitrary JavaScript and basically get arbitrary code execution. So if you see something like this, you've got a paragraph which substitutes in user input. If you actually put in your own script tags into this user input, the browser will actually read this, do the paragraph, see a script, execute this script, put a blank space there, and then just continue with the rest of the user input. Going back to the 3 types of XSS, you can do it with stored XSS. This is when the attacker sends the payload to the server. the server stores the payload somehow, either in a file, an SQL database, anything like that. And then when the target then goes to try and view the infected page, the server sends back the appropriate page plus the payload, and then the target executes the payload. This is as opposed to reflected XSS, which is when the XSS never touches the server directly because it's encoded in something like a GET requests parameters or something like that. Something that the website's JavaScript reads, or something that the server-side framework reads and then substitutes into the HTML document. So in this case, it's never stored. So you can pretty much just put it into a URL, give that URL to someone, and then they read it, or they click the link, they execute it. Now, the last one here isn't really common, but it is interesting. There is something called a DOM XSS. This doesn't use any sort of networking per se. It can actually be done on your local machine, disconnected from the internet. All you really need is a JavaScript engine. So this is any type of XSS which messes with the web browser's DOM in particular. The DOM being the sort of data structure that JavaScript uses and how all its objects and data is stored. So imagine, if you will, a website which allows you to upload an image and mess around with it, change its color values, stuff like that. That would be using JavaScript to read the image and then execute some commands on that data. What if you had a malicious image that could exploit something in that JavaScript to execute code? Well, then you would send the victim the website to upload the image to. You would send the victim the image, they upload the image, the payload executes, and suddenly, without actually talking to the server at all, you can get arbitrary code execution, even because sometimes the browser actually caches the web page. So sometimes when you're accessing Google, if you've accessed it 2 hours ago, it won't bother sending you sending a request and taking up traffic resources, because Google's always Google. It's always the same. So yeah, that's a really interesting one. Not really seen in the wild though. Another sort of exploit is XXE, or XML external entity injection. They really like their X's. So sometimes websites will use something called XML, which you'll notice here looks very, very similar to HTML. That's because HTML is actually built on top of XML. So what XML is, it's the data format that uses tags and then puts data between those tags. In XML, you can actually make arbitrary tags. So in this case, I've got 2 child tags. You could very easily make that 2 dog tags, for instance. So another thing that XML sometimes lets you do, depending on the target settings, is XML lets you get an external entity and substitute it in. So in this case, we've got an XML document which will make an entity in memory, which has the contents of the file etc passwords. And then later on, when it gets to this child tag, it will substitute the contents of that file into this child tag. Now imagine a website that prints out whatever is inside the child tags. Well, in that case, you would have, in normal circumstances, you would just see the text, "I am a child." In this sort of malicious circumstance, you would be able to arbitrarily read files, which is very useful, especially in cases where it's the password for the computer. Another sort of attack is template injections. So previously, I talked about how the front end was all React and Vue and all that. And then I mentioned that there were dynamic web pages that used Flask and Django. Flask and Django are basically the same thing. They are interpreted languages, right? So they're the exact same as JavaScript, except they're being executed on the server instead of the client. So what if you could mess with the server's templates the same way you would mess with a HTML document? You could arbitrarily put in Python code, and if it's not sanitized properly, then Django will read its own request as a text document, because pretty much everything on the web is a text document, and it won't be able to tell between Python commands and data commands. And so it's essentially XSS, but you're targeting the server instead. These aren't really an old attack per se. You could kind of do this with PHP, but it has really grown in prominence over the last few years as things like Django and Flask have become more popular, because they suddenly you've got all manner of websites that aren't just serving, but also doing like complex mathematical stuff in the background. And Python itself is a shit show. This is just when you put Python on the web, it gets worse. The last one for sort of attacking the backend server is command injection. Command injection is whenever you put user data into a OS command. In PHP, this is anytime you use the exec command, right? So if a web server takes user data and it puts it into a shell command, well, then it is executing anything that the user puts in. And typically that's fine, because the user wants to read a file, right? So cat myfile.txt. And you have a website which gets the name of myfile.txt and substitutes it in to that cat command. Well, shells are very smart. You can actually chain multiple commands together, right? In Windows, you do this with the ampersand. In Bash, you do this with the semicolon. So what if you were to put into the website myfile.txt semicolon cat or semicolon ls, which is the listing command? The result you would get back from the terminal would be the contents of myfile.txt followed by the contents of the ls command. So you'll start to see a sort of you should start to see a sort of pattern emerging here with web exploits. In the words of Richard, I think it was the vice president last year of MonSec, he said that at the end of the day, all web exploits are pretty much the same, because you're always exploiting the same string parser, because this is all just text documents, and we're exploiting how those text documents are being executed. So in XSS, you tricked it into doing JavaScript with the script symbol. In command injection, you're tricking it into doing commands with the semicolon. And in SQL, which is another interpreted language, again, another stream of text, another text parser, you're doing the same thing. Imagine for a minute that you have this SQL command. You have select star from table where username equals Daniel. This should return all of the users that have the username Daniel. But what if I put in this string instead? Instead of searching for Daniel, I searched for apostrophe or 1 = 1 semicolon dash dash dash. To the server, it would look like this. What the SQL server behind it would see is this ending with the semicolon, and then these dashes here tell the server to ignore everything else because that's just a comment. Typically, you would find this in something like a search function on a website. If you're able to search a database at all, or for instance, or even in this case, you could do this in a login screen. We actually have a demonstration up at the moment. If you go to bank.monsec.io, which is an intentionally vulnerable website, that you could literally use something like this to get into, just because we don't sanitize the inputs there. And it takes whatever you put into the username field and sends it directly to the SQL server. Cool. So we've broken the front end. We've broken the back end. Now let's break the protocol. The protocol, if you remember, is stateless, so it has no memory. Or rather, it has memory in the form of cookies, which are text documents. So what if you were able to get an XSS on a user's machine? You are able to execute arbitrary JavaScript, and you are able to make their web browser make a GET request to anywhere in the world. Well, you could make them execute a GET request to go to your website and pass in and request the resource that is this encode document.cookie. What that will do is that will get the web browser's cookie. It will encode it into text with base64, and then it will ask your server, hey, do you have this this document, this resource, right? You could very easily then set up an automated system to say, anyone who requests a document I don't have, output it as just as text. You could then go into your browser, copy and paste whatever was here in the resources, and set your cookie to be that and decode it from base64. And now suddenly you have the same data that your target has. It is the exact same. And so when you make a request to that website, you give them the authentication code of the other person. Now, HTTP doesn't know the difference between who is asking what. So most of the time, unless there is any like firewall blocking, IP blocking stuff, most of the time, it will send back information as if you are that other user, just because you've messed with the text documents. This is actually called session hijacking, for obvious reasons. Cool. So that's all well and good. You've got the theory of it. You've got kind of the idea of how web hacking works. But the real job relevant question is, how do I actually do this in the real world? You could do this just manually, finding servers, throwing it out there, but that's time consuming and really, really boring. So instead, you would use tools. But before you go and make a tool that will try and steal the cookie from every website, or you make a tool which will fuzz every single URL on the internet to see if there's any XSS, maybe be a bit smarter about it. When you're attacking a real target, you should first enumerate. So gather as much information as humanly possible. This is so you can actually find the attack vectors of the website you're attacking. So some really good tools for this. You can use Nmap if you want to enumerate all services on the machine. This will typically return to you if you're attacking a web server. It will tell you if there is a HTTP, a HTTPS, and sometimes you get other goodies like an SQL server. You may not be able to access the SQL server, but just because you know that the SQL server is there, you can be better informed that maybe you could get an SQL injection somewhere. For actually enumerating the website itself, you can use a tool called Nikto. This is pretty much just a program that will try every sort of HTTP thing possible. So it will try to see if you can arbitrarily upload files. It will tell you exactly what the server will let you do. It will tell you what the server says you can't do, but you can still do anyway. It takes about 40 minutes, but well worth it because this thing is kind of the holy grail for generalized enumeration. One thing Nikto doesn't do, though, is show you anything that's been hidden. So yes, google.com is accessible. Everyone knows about it. But what about google.com/totallysecret.txt? You would not know about that without sheer brute force. So that's what Dirbuster does. It takes a Word file, which Kali has in Word /user/share/word lists. It takes a text file and it will just keep throwing requests at the server like, hey, do you have readme.txt? Hey, do you have robots.txt? Hey, do you have login.php? So that's really good for that. And finally, whilst all these things are running, just do some manual enumeration. Look at robot.txt, see if you can find anything that they don't want Google to find, or they don't want you to find either, or even just mess around, see if you can do any SQL stuff, see if you can get any 500 errors from the server. After that, once you actually know what you're doing, you know that there's an SQL injection here, or you know what type of web server is being run, you can actually get onto exploiting it. Some good ones for this, if you're doing SQL injection, SQL map. This is a Python tool that is kind of like Nikto, but can become Nikto on steroids and just throw whatever it knows at the web server. This isn't exactly the quietest thing. So if you have if you're going up against the NSA, who is tracking everything you do, it's not exactly subtle, let's put it that way. But it is really effective. Other than that, if you know that it's a particularly, if it's a WordPress site, use WP Scan, or if it's a Drupal site, use Droop Scan. Both WordPress and Drupal have had very, very severe exploits in the past. I think WordPress in particular has had multiple command injections in the past, which is terrible. These things will help you find it. Drupal Scan also works with the Drupal Armageddon, which is a is a command injection vulnerability that was found, I think, like last year, something like that. A lot of websites still have it. But yeah, that's pretty much all for this sort of touch on everything in web that I can think of. Didn't go over any Wireshark, but we'll leave that for next week's forensics. If you feel inspired, if you actually want to mess around with this sort of stuff yourself, some really good ways of doing that is just finding Hack the Box, even just getting into Hack the Box itself, getting the login is really challenging and is a web-based challenge. You can also do challenges from VulnHub, for instance, which is basically VMs that you download and you try and hack. Or if you get bored of all that, why don't you make a challenge? Throughout this semester, we will be conducting, I guess you could say, we will have submissions open for Level Up CTF. This is our kind of community-made CTF for MonSec by MonSec. So if at any point you find something that you're really enjoying and you want to show off to people, you can make a challenge, throw it up on the GitHub, and at the end of semester, we kind of put them all of the challenges online, there we go, to kind of show off what we've learned. Just a bit of fun. Don't worry if it's not super complex. Anything really counts. Remember to go to go.monsec.io/survey. Tell me how I went. Tell me if I was too fast or if you actually understood what I was saying. Other than that, you can contact us at team.monsec.io. Talk to us directly through Live Messenger on Discord, and be sure to come back next week for monsec.io for the next workshop. Go.monsec.io/live. And that's all.
All right, thank you, Daniel. I will actually share a few things real quick, however. All right, so what I'm showing right now is pretty much one of our go-to for if you want to feel like you're achieving something when it comes to web securities, which is NatAs. So this particular website, Over the Wire, they have two different subdomains to teach you a little bit about hacking. First one is NatAs, the other one is Bandit. I know at least Leo should be a bit familiar with both of those ones after last semester. But essentially, these ones have a bunch of levels where they slowly take you through all the different skills, or some different skills, which we've touched on before. First ranging from quite literally just, the first can be as simple as quite literally just inspecting elements, to more advanced ones such as searching across the domain, manipulating the GET and POST requests, and looking at the cookies from memory at least. And then the other thing to show, which most of you guys should have seen before, is a MonBank, if you haven't seen it already. I'm not going to demo it right now, but however, if you go to our YouTube channel, we do have a video on how to crack this, or if you just want to have a bit of a crack at any SQL commands, you can execute them from either of these since we don't sanitize them particularly well. And yeah, if there are any more questions about anything within this presentation or about the club in a whole, let us know now.